The current Midtown Tunnel between Norfolk and Portsmouth, Virginia, is one of the most heavily traveled two-lane highways in the Commonwealth. The proposed second Midtown Tunnel will increase capacity, reduce congestion, and provide safe and efficient operations for years to come. The SKW construction team is comprised of a joint venture between Skanska USA Civil Southeast, Kiewit Infrastructure Company, and Weeks Marine. They will be supported by a design team of Parsons Brinkerhoff and Volkert and Associates. A significant example of this team's previous experience in immersed tube construction is the world's widest underwater vehicular tunnel, the Fort McHenry Tunnel in Baltimore, constructed by Skanska and Kiewit and designed by Parsons Brinkerhoff. The Elizabeth River Tunnels project can be separated into 5 distinct areas of construction. The second Midtown Tunnel itself, which will be built using immersed tube tunnel methods, the Norfolk approach, the Portsmouth approach, and an extension of the Martin Luther King Expressway, which will provide a direct high-speed connection to I-264. And finally, rehabilitation of both downtown tunnels and the existing Midtown Tunnel. Although the majority of the immersed tunnels in the United States have been steel shell concrete tunnels like the Fort McHenry and the existing Midtown and downtown tunnels, concrete tunnel elements are being fabricated both for their cost savings and flexibility of design. Tunnel fabrication will involve the construction of 11 rectangular reinforced concrete tunnel elements with temporary bulkheads installed on each end so the tunnel elements will float. The tunnel elements are being fabricated in Sparrows Point, Maryland, and will be towed down the Chesapeake Bay to the job site where they will be safely moored and prepared for immersion. Floatouts are currently planned in 2 phases, spring 2014 and spring 2015. 2 to 3 tunnel elements will be outfitted at the VPA PMT dock at a time, with remaining tunnel elements temporarily moored while awaiting a berth at the VPA PMT. Prior to the installation of the elements, trenches will have to be excavated on land and in the Elizabeth River. Approximately 1.5 million cubic yards of sediments will be excavated, with approximately 10% being disposed at an upland facility and 90% approved for ocean placement. For the land excavation, existing abandoned timber piles and shoreline debris would be removed, and a steel supportive excavation system installed. Ground within the system will be removed to make way for the new tunnel. Installation of the immersed tunnel elements will require dredging a trench using a dredging barge and crane with clamshell bucket. The trench will be approximately 55 feet wide at the bottom and filled with a minimum of 2 feet of gravel that will be leveled to the proper grade using a screed barge. To complete the screed foundation for one immersed tube requires 3 setups. Placing the tunnel elements will be performed using a special catamaran barge, with placing girders spanning the opening between the barge hulls. This placing barge is capable of receiving, supporting, ballasting, and lowering the negatively buoyant elements. To achieve negative buoyancy, water ballast tanks will be installed in each tunnel element. Removable survey towers, mounted on the outboard end of each element, combined with global positioning system technology, will be used to control the horizontal and vertical placement of each element during installation. Each tunnel element being placed has a thick rubber seal attached to its inboard end. It is compressed against a steel plate on the outboard end of the receiving element, and when water is pumped out of the joint chamber between the concrete bulkheads, it creates a watertight seal between the new and previously placed element. The approach for the placement sequence is to install each of the 11 tunnel elements sequentially, beginning mid-2014 on the Portsmouth side and moving toward the Norfolk side. Elements will be placed at a rate of about 1 per month, with the placement of the last element occurring mid-2015. The closure pours will be done in the dry on the Norfolk side, allowing for any necessary adjustments. Approximately 2 1/2 of the elements fall within the Federal Shipping Channel. Backfill of the installed immersed tunnel requires 3 distinct backfill operations. Immediately after an element is placed, the locking backfill is placed first to prevent any horizontal movement of the element. The tunnel elements are then covered with ordinary backfill designed to provide a protective cover over the tunnel. The final layer of backfill will consist of armor stone, placed to protect from scour and from dragging ship anchors or other possible marine impacts. Backfill operations will be performed using 2 methods: placing the backfill with a specialized barge equipped with tremie pipes or clamshell bucket. The tunnel interior will largely be determined by the required traffic clearances, requirements for ventilation, fire protection, and evacuation. A longitudinal ventilation system based on jet fans will result in the smallest cross-section while having the added benefit of the lowest future maintenance costs. Fireproofing mounted directly to the tunnel walls and ceiling, coupled with a sprinkler deluge system, will provide protection from potential fires inside the new Midtown Tunnel. The design calls for an egress corridor accessible from the main tunnel by fire-rated doors spaced 300 feet apart. The Norfolk Approach Roadway connects directly with the existing westbound lanes, thereby minimizing work within the existing interchange. The vertical alignment required to meet the Norfolk Approach will necessitate an expansion of the current peninsula by installing some earth fill in the river. This required expansion was kept to a minimum. The access road to the existing tunnel vent building will need to be permanently relocated. The Portsmouth Approach Roadway yields a simple curve that fits within the existing right-of-way. The Port Access Road will have to be relocated permanently, and other temporary relocations of roads and railways will be required during construction, particularly within the port property. The relocation of the access roads and other approach roadway work will result in some minimal right-of-way impacts in Norfolk and Portsmouth. The Martin Luther King Expressway extension and interchange will provide a direct freeway-to-freeway connection between I-264 and the Midtown Tunnel. The Elizabeth River Tunnels project and its 5 distinct areas of construction, the Immersed Tunnel, the Norfolk Approach, the Portsmouth Approach, the extension of the Martin Luther King Expressway, and the rehabilitation of the downtown tunnels and the existing Midtown Tunnel represent a smart growth investment. An investment in safe traffic operations, preventative maintenance, and rehabilitation that will keep the area's roads and tunnels running smoothly and preserve both the quality of the assets and the quality of service provided to the traveling public.